Alright, Assalamualaikum and good morning to everyone. So today we will look into chapter 7, which is the development of entity relationship diagram. So after completing this chapter, you should be able to identify the main characteristic of entity relationship component. And I think we have covered this thing on the previous topic, so which is the entities. You need to have the attribute, and also you need to have the cardinality or relationship. And second, you should be able to describe how relationship between entities are defined, refined, and incorporated into the database design process. See how ERE component affect database design and implementation, and understand the real-world database design often require the reconciliation of conflicting goals. So what is entity relationship model? So basically, it is a model that consists of three components or three important components, which is entities, attribute, and relationship. Entities is the name of the table. Attribute, the thing that describe the table. Okay, for example, let's say you have the entity of a room. Okay, you have an entity of a room. So how do you describe the room? Okay, so usually room will have a facilities. What kind of facilities? Okay, such as you should have an aircon, fan, lighting. You could have an LCD and so on. So those are the things that can become the attribute of those entity. And usually room will have a number. For example, if you are going to a hotel, so each hotel has its own number. So those number will guide you on whenever room that you are going to sleep on. And then relationship. So as we look last week on the previous topic, so entities will have a relationship. Okay, the most easy one, for example, student with result. Student will have many results, and many result will be owned by one student. So entities, which is the object of interest to the end user, and it is usually correspond to the table, not a row, in relational environment. In chain, so in database we have two popular method, which is a chain and Crawford. And something you can use UML notation. However, most of the time we'll be doing chain and Crawford model. So this thing, an entity is represented by a rectangle that contains the entity name. And usually this name will be in a noun and written in capital letter. So characteristic of entities, it requires attribute. It must have a value and cannot be left empty. If you have an empty entities, you can remove those entities because it will not work. It will have no meaning to your database design. And optional attribute does not require a value and can be left empty. So you need to decide on the attribute, okay, whether you want to have required or optional. Required means that those things must be fulfilled. If you don't fulfill those fields, or if you didn't give any value to those fields, so you cannot save the data into the database. Okay, for example, the required field is usually your email address, your phone number, your name, your username, your address, line 1. Address usually have a combination of optional and mandatory. Line 1 is usually mandatory because you will always have a line 1, but not all address have line 2. So line 2 we can make it as an optional. It can be left empty or you can put something on it. And sometimes you can have domain set of possible value for given attribute selection. Okay, for example, let's say cost. So you can select all the costs that are available for you in the UITM. And also you need to have identifier, one or more attribute that uniquely identify each entity instance. Okay, it must be unique. This thing we call it as a primary key and first key. And you can have composite identifier, you can have composite attribute, simple attribute, single value attribute, and also multi-value attribute. So the example of chain model and Crawford model. So whenever you are doing your assignment, you can select either one, whether you are doing a chain model or Crawford model, but do not mix it together. Okay, for example, you have the entity of a student. So how do we describe the student? Student, we have name, first name, last name. That depends on how you want to develop your system. For example, in Malaysia, we don't usually use first name and last name. So maybe you can just put the name into one column or one attribute. Okay, and then initial, maybe they have an initial, student email and student phone, or what else that you can use for a student. Okay, IC number. If you look into this chain model or into the example that is given to you, there is no primary key, means that there is no unique ID to identify this attribute or to identify this student. It could be anyone else. Okay, it could be student A, it could be student B, it could be student C, and so on. So you need something, a unique thing that can identify the student. The things such as your student ID, or maybe IC number, or email address. So email address is uniquely only applied to you, only applicable to you. So those things can also become the primary key or foreign key, or something that uniquely identify your attribute. So the example of multi-value attribute in entity. For example, you have entity of car. Okay, and then you have four attribute, which is car, VIN number, mod code, car year, and car color. Okay, so if you look into the attribute of color, so for car, you can segregate or differentiate color into several segments. Okay, such as this one. You can have car top color, car trim color, car body color. Yeah, however, it depends on you as the database designer, whether you want this to be as exactly or as small as possible that describe the whole car, or you just want to put it as a general. Okay, for example, I have a white car, I have a black car, I have a red car. Okay, so it all depends on how you develop or you design your database. Right, so this direction of derived attribute, so you will have a relationship. Okay, the thing that will link between one attribute to one entity to another entity. So advantages and disadvantages of storing derived attribute. So the advantages, it will save CPU processing cycle, save data access time, data value is readily available and can be used to keep track of historical data. Okay, derived attribute, if you did not store, save storage space, computation always with current value. Disadvantages require constant maintenance to ensure derived value is current, especially if any values used in the calculation change. So derived value means that you will have a default value. Okay, default value they are stored for selection. The best thing is that if you have a derived value, you will have a consistent responses from the user. Okay, for example, let's say if you don't have a derived value, okay, you want an information about user, okay, they need to key in their state, okay, their current state. For example, let's say me as a user, so I put it Kelantan. Okay, however, another user put it Kelantan Darul Naim. Okay, and another user put it KLTN, and another one put KTN. So for one places, you have four different responses. So to avoid this kind of thing, so you need to have a derived value or derived attribute. And association or cardinality, this one we also discussed. So we have about three, which is one to one, okay, one to m, which is one to many, and m to n, which is many to many. So we have existent dependence. Existent dependence means that the dependency of one attribute depend on another attribute. Okay, for existent independent means that it can live or it can stay on its own. Okay, it exists apart from all of the related entities, referred to as a strong entity or regular entity. For example, table user. Table user doesn't rely on another table. Okay, but however, another table will rely on table user. Also, we have a weak relationship and also we have strong relationship. A weak relationship is primary key of the related entity does not contain a primary key component of the parent entity. It means that, for example, if you have a relationship between student and result, however, you don't have the primary key of a student into the result table. So that's why we call it as a weak entity. And condition of two entities usually existent dependent mean that the existence of this entity will rely on another. The most easiest way or the most easiest example is between customer and product. Okay, so customer will order a product. So order will become the weak entity. So the relationship between customer and product will be M to M or many to many. So when you have many to many, automatically you will have a middle entities that we call it as a weak entity or bridge. So this weak entity will rely, the data will rely on both the customer and also the product. So the example of a weak entity in NERD. Okay, for example, employee has dependent. Okay, so employee noun will be the primary key. So dependent noun would be the primary key for the dependent. So sometimes employee can have a dependent, sometimes employee doesn't have a dependent. So the dependent attribute or the dependent entities will rely heavily on the employee. So if employee is all alone, he or she doesn't have any wife, any family and so on, so the dependent entity will not exist. So the example on how you develop the ERD. So the example of weak entity in a strong relationship. And relationship, we have optional participation and mandatory participation. Optional means that one entity occurrence does not require a corresponding entity occurrence in a particular relationship. It means that when you are adding another data into a certain table, you don't need the use of the primary key from this table or from this entity. While for the mandatory, it is mandatory to have. Yeah, mandatory means that you need to have the primary key, the foreign key in order to make a relationship between the table. Okay, for example, course generate class. So class is optional to course. So maybe you can take that class or you don't want to take that class for this semester, you want to another class, you want to another course, so that will be a optional. Mandatory means that you need to get that one. Okay, mandatory means that you need to get that one. For example, if you are in the semester 1, you have to take all the subjects that have been given to you. Okay, however, when you go to semester 2, if you have any subject that you fail to complete or you fail to pass the subject, so you can take the subject as an optional. So relationship we have degree so indicate the number of entity or participant associated with a relationship. So we have a couple of type of relationship. We have unary, binary, ternary, and recursive relationship. So unary is association is maintained within a single entity. Binary, two entities are associated. Ternary, three entities are associated, while recursive relationship exists within a single entity type. So the example of a relationship, okay, the first one will be the unary, second one will be the binary, ternary, and ternary relationship in terms of logical. Okay, so ternary means that one entity rely on another three entities. And relationship can exist between occurrences of the same entity set. Okay, you can make a complete system by using just one table. Okay, however, there's a lot of things that will involve, especially in terms of programming languages. So that one we call as array. Alright, so the example, for example, employee is married to, employee manage, cost, has. So you can have one table, so don't worry. It's all depend on your own creativity. However, it is advisable to have different table for different entities. Associative composite or composite entities used to represent M2M relationship between two or more entities. So if we have a 1-to-M relationship with the parent entity, so this is the extra entities that will be produced when you have a M2M relationship. Okay, this happens when you are doing the normalization of your database. Normalization will be on our subsequent topic that will be on next week. Alright, so the example of a composite. So you will have a composite key in the middle of the relationship. So this activity involves in building an entity relationship diagram. First, you need to create a detailed narrative of the organization, description or operation. Identify business role, identify main entities and relationship from the business role, develop the initial ERD, identify the attribute and primary key that adequately describe the entities, revise and review the ERD. So whenever you are going to develop this ERD, so you need to follow this step. And for the task, for this week task, so I want all of you to develop an ERD for an e-commerce system. Okay, I want you to develop an ERD, a complete ERD that have a relationship, that has the attribute, and also have the entity. So you should have about 10 entities. Okay, a minimum of 10 entities, and then please submit it to me via the Google Drive. So the class rep, please create the Google Drive so that others can submit via the Google Drive. Alright. So that will be your task, and it needs to be submitted before the end of this today. I think before 5 p.m. Okay, you need to submit this before 5 p.m. Alright. So the example of entity relationship diagram. Okay, school we have a professor, school we have a department, and you need to relate those things. You need to have a primary key, also you need to have a foreign key. Okay, so another one. Okay, department offers cost. So how do we link department and cost? So department code will become the foreign key. So the example also. Okay, another example. So you can look into this example. The 7th Tiny College. Alright. Another example. So this is example of how you develop your ERD. For example, school operate Okay, entity. So you will have connectivity. So whenever you are doing your exercise, you need to understand the business role of an e-commerce system. What should you have in e-commerce system? Try to look into Shopee, try to look into Lazada on how they work, and try to replicate those things. Try to identify their business role and incorporate those business role in your ERD development. You can use either chain or profit model, either one. Okay, challenge designer must often make design compromise that are triggered by conflicting goal, and database design must conform to design standard. High processing speed may limit the number and complexity of logically desirable relationship. Maximum information generation may lead to loss of clean design structure and high transaction speed. So this is the thing that you need to consider whenever you want to develop a database. So there's a lot of things. Sometimes you cannot follow directly the one that can only be used manually, because when you want to convert manual into the system, you need to follow the system. Sometimes you have to reduce several steps in order to make it more efficient. So the example of implementation that you will do whenever you are doing your database design. Okay, first implementation, maybe you only have one table, and then you need to separate into two tables, and maybe there's a new thing that emerges, so you need to create more table, add more table, or you need to reduce more tables. So that's how you compromise with the design of a database. Alright, so I think that's all for this topic. So let's recap. So in this topic, you learn about the ERD, the chain model, the Crawford model, the activities, the attribute, and the relationship. Okay, so ERD may be based on many different ERM and so on. So whenever you are trying to develop a database, first you need to understand the business role. Business role will guide you on how you want to develop the database, and the entities, the relationship, the attribute will come by itself.